Hi students, today I am coming with a CBSE numerical. The question is, net capacitance of three identical capacitors in series is 3 picofarad. What will be their net capacitance if connected in parallel? Also, find the ratio of energy stored in the configurations. So, two type of configuration is there, configurations. If they are both connected to a common power supply, that is if both are connected to the same source, connected to the same source. Look like a question is difficult, but once you practice one or two sample like this one, easily you can do this one. So I will try to help you how to solve this one. I have easy step for this one. First of all, you read the question more than one time, that is required. So from the question, when you read, you will understand there are three capacitors exist, but they are identical capacitors. Since they are identical capacitors, we will not maintain C1, C2, C3. Instead of that one, we will maintain a single letter like just C, because they are identical. No need to mention C1, C2, C3. So so let C1, C2 and C3 be the capacitance of three capacitors. So C is the capacitance of each capacitor. Why C is written? Because they are identical. So we are going to write C1 is equal to C2 is equal to C3 is equal to just C. And now we call the rule. What rule? When C1, C2 and C3 are connected in series, we learned about series connection format, right? 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. But in this case, we will not write C1, C2, C3. We will write 1 by C plus 1 by C plus 1 by C, because they are identical. And in the question it is given the effective value in series is 3. So 1 by 3 is equal to 1 plus 1 plus 1 by C. So is equal to 3 by C. Just to do a cross multiplication to get the value of C. So C is equal to 3 into 3 is equal to 9 picofarad. So simple, right? So individual value found it. So each value is C1 is 9, C2 is 9, C3 is 9. Why I wrote separately? Because the time when we consider the parallel, we need these values. So when C1, C2, C3 are connected in parallel, when they are connected in parallel, the rule for parallel is Cp is equal to C1 plus C2 plus C3. So it's equal to, here the values are 9, 9, 9. So 9 plus 9 plus 9. So it's equal to 27 picofarad. That's all. So we found individual value, we found parallel value. Now there is a confusing part when we do the next part. Many students make one mistake. I will tell that is mistake, which is that mistake. Energy stored in the capacitor equation is U is equal to half C V square. Half C V square. So here the ratio we want to find. So in series ratio with the parallel ratio, US by UP is equal to equation is half CS V square and half CP V square. Why I am not writing V1 V2? Because connected to the same source. V square cancel. Now while substituting, half and half also cancel. Substituting, some people fill up in the place of CS with the value we calculated. That is actually C1, C2, C3 values, not CS. CS value given in the question. So 3 divided by CP value is 27. After simplification, we will get 1:9. So ratio of series to parallel connection to the same source is 1:7. What do you feel? 2 mark question, very simple way we can do it, very easily we can do it. So I will just show you one more sample without much steps, very small, within 1 minute, less than 1 minute we will solve this one. Do a similar question for CS is equal to 2 microfarad. This much enough, because all other remaining concept remains same as previous question. So how we will go about this one? Each capacitor, C1, C2, C3, considered as just C. So 1 by CS is equal to 1 by C plus 1 by plus 1 by C plus 1 by C. So 3 by C, do the cross multiplication, you will get 6 microfarad. Now CP calculate, C1 plus C2 plus C3, so 18. Understandable, 18. Now the ratio calculation, US by UP, remember same source, and cancellation of V square will be there, half and half cancel. Just to do the ratio of CS value which was given in the question 2 and CP value we found it 18, so 1:9 again. This time understood, this much work only required. In the first video I explained step by step for students those who are average and below average. Students, thank you, have a nice day, we'll see you in the next video.